Hello and welcome to this Java interview coding challenge video where we don't just solve coding problems. No, we do more than that. We learn how to tackle them in an actual interview setting, right? How to solve the problem and what to say, what to discuss to maximize your chances of success in an interview, all right? In this video, we're going to be tackling LeetCode problem 705, designing a hash set. Right? How do you design a hash set? Here's the problem statement. The interviewer tells you, design a hash set without using any built-in hash table libraries. Okay, this is what the interviewer asks you to do. Okay, and if they leave you at this, it's up to you to ask further questions. Right? You need more detail. Here is some detail that you can kind of extract from the interviewer. Like, what are the APIs that you need? Hashset does a whole lot of stuff, but there are some core APIs that Hashset provides. Okay, so your design, let's say the interviewer answers your questions and says, here are the things I want you to do. Okay, so here are three things you should be doing. First is adding a value. A Hashset needs to be able to add some value. So given an add method, your class, your custom implementation of Hashset needs to have an add method, which takes in a value and then adds it, inserts it to your hash set. All right. Then there needs to be a contains method, which takes a value and sees if it actually exists in the hash set, right? And it returns true or false if it exists in your hash set or not. And then the third one is remove. You need to check if you need to remove a given value from your hash set. If the value exists in the hash set, you remove it. If the value does not already exist in the hash set, you just don't do anything. So these are the three operations that your hash set needs to perform. Now, how you do them is up to you, but this is what your program needs to work with. Okay, so here is the starting point that's given to you. All right, so here is my my hash set class. Okay, I have a constructor where I can initialize my data structure. I need to have my data structure, right? I need to use some data structure to hold on to the data because they're going to be sending, they're going to be doing adds a bunch of times, remove a bunch of times. So I need to track them. So this is where I'm going to track. I'm going to hold my own data structure and initialize it over here. Here's the add method, which interestingly takes in an integer. Okay, so this is a question that you can ask the interviewer if they don't provide you this information. What's the data type that I need to be tracking it in? Right? If they say anything, well, then it becomes a little bit more complicated. But in this particular question, in this particular LeetCode challenge, the starting point is an integer. So let's work with that. Right? I've given an int key, and I need to add to it. The return type is a void in the starting point, so I don't have to return true or false like an actual Java hash set does. The actual Java hash set actually returns true if the underlying data structure got modified as a result of the add. If that element was already there and it didn't modify anything, then the add returns false. Okay, so you don't have to do that. It's returning void. That's cool. Makes it easier. Remove takes in a key, and then again it removes it. Again, no return type true or false if it actually modified the data structure, just a void. Okay, so if it did not have the value, again you can just return silently. And then there is a contains method which takes in the key and then it returns a Boolean if it actually contains it or not. This thing has to return a Boolean, otherwise there's no point in the contains. Okay, so these are the methods that you need to implement. Okay, you need to write it. So there are a bunch of assumptions in the LeetCode problem. So if the interviewer is getting their source of questions from LeetCode, they might share the same assumptions with you. So here are the assumptions on LeetCode. Okay, first of all, there is a range of values. It's an integer, so there needs to be a range of values. So the interviewer says, these are the range of values that I can add to my hash set. Okay, so the range is from 0 to this number. How many were zeros here? Okay. You don't get more than that or less than that. No negative numbers, nothing of that sort. Okay, that's great. But the other assumptions, the number of operations will be in the range of 1 to these many. Okay, there'll be at least one operation, and there will not be more than this. There will not be more add, remove, contains calls than this number. Okay, good to know. And then, please don't use the built-in Hashset library. Okay, that's what the LeetCode problem says. Let's say the interviewer asks you this. Okay, now there is one ridiculously easy way to solve this problem. Okay, if you think about it, it's one ridiculously easy way. You're not supposed to use the Hashset library. Well, what about if I use something else? Can I use a tree set? That'll work, right? I can just stick a tree set in here and then say add to the tree set, remove from the tree set, contains tree set.contains, right? You're basically delegating your work to the tree set. It's going to work fine. And if the requirement is just don't use Hashset, I'm going to use tree set, or I'm going to use some other set implementation. It's going to work just fine. They're not using Hashset, right? They're not using the built-in hash table. Well, let's assume that the interviewer doesn't want you to do that, okay? Otherwise, there's no point in asking this question. It's like you can solve this in a minute. Let's assume the interviewer says no set implementations, right? It's not just Hashset. There is no built-in set implementations. You have to write your own set implementation. So in that case, well, there is something for you to do, all right? So let's say the answer to the question, can we use a different set implementation, is no. Okay, let's assume no existing set implementation. Now, there is a simple way to solve the problem, which is not efficient, but it will do, right? And the simple way is leveraging the fact that they've given you a range. Okay, they've given you a range and said it's the number that you're going to get as input is going to be between 0 and this number. They're all going to be integers, okay? And it's going to be between 0 and this number. Well, then you can actually leverage this fact to implement it a simple way, okay? The way that works is to just create a Boolean array, okay? They're all going to be numbers, okay? And they're all going to be within this range. So just create a Boolean array of size, this one, which is basically the range plus 1, okay? Because we're looking at a 0 index here. And I'll tell you why the 0 index matters in a bit. So now what you need to do is you need to just keep track of whether somebody added a certain number or not. So what you need to do is just go to that particular index. Let's say somebody adds 5, okay? So go to that index 5 of this Boolean array and set it to true. That's it. If somebody later says, okay, contains, what you need to do, you just need to look at that index 5, see if it's true or false. Have I set it as true? If I've set it as true, well, then it contains it. What does remove entail? Remove basically says go to that index and then make it false. You're basically removing it. So basically you have like an array where it's like a check, right? Anytime some element gets added, you're just checking that particular location in that array. You're not saving the number itself. You're checking that location of a Boolean array so that next time somebody asks you for it or somebody removes that element, you're basically unchecking that or making it as false, so to remove. And for contains, you're basically just seeing if that is checked or not, okay? Adding a number n is basically setting array of n equals true, okay? Removing is basically setting array of n equals false. And then contains is just returning array of n, right? Whether it's true or false, okay? This is the reason why we had to add 1 to this. The capacity is whatever is 0 over here. I had to add 1 because it's 0th index, right? Or you can say n minus 1 in all of these cases, and you can have an array of size 1, 0, 0, 0, 0, 0, 0 instead of 1, okay? So simple implementation. This is going to be super fast, right? You're just looking at array indexing, so it's going to be super fast. No collisions. It's going to be faster than Hashset, okay, if we were to use Hashset, because Hashset kind of does the collisions and all that stuff. It's going to be even faster than that, but the memory utilization is going to be huge, right? So here's the implementation. We're just going to run through the logic, and granted it's not ideal, but this is one way you can solve this problem, okay? So what are you doing over here? First, I'm going to create a Boolean array, which is going to keep track of my, is an element available or not, kind of a thing. And in my hash set, I'm going to initialize it with this number because I know that this is going to be the maximum capacity. Okay, it's a Boolean array. Since the default Boolean value is false, I don't have to initialize the value itself. I just have to create a Boolean array and I'm done. Now, if somebody were to add an element to it, what I need to do is array of that element equals true, right? So I'm checking that element in my Boolean array. When somebody adds something, right? They can add 10 elements. I'm going to check those 10 things. Adding the same element again is not going to matter because I'm just setting the value as true, okay? Now, removing is fairly simple. I'm going to set the value as false, kind of like unchecking that location. And contains is fairly simple as well. All I'm doing is I'm returning array of that key. If somebody had added it, it would be true, so this is going to return true. If somebody added it and then removed it, it's going to be false, so this is going to return false. If nothing was added there at all, it's going to be false as default, so this is going to return contains is going to return false, right? Simple implementation, very, very simple. What's the time complexity? Yeah, so of 1, right? You're just doing a lookup. It's constant time. It's independent of how many elements you have. The space complexity is crap, though. You're looking at O of n, right? If you imagine allocating so much space there, granted it's Boolean, but still it's not good. Okay, so if this goes, if the interviewer says, yeah, this is a perfect solution, then you're good. But let's say you have a picky interviewer and they say, no, this is not what I have in mind. I want you to actually implement a hash set yourself. Okay, so in order to avoid that problem, first convey your approach, right? Convey, well, is a Boolean array okay? This is what I'm planning to do. Is it okay? If they say no, don't even go with the code. Okay, if they say yes, that's fine. But if they say no, let's say you have to implement it yourself. Okay, well, you can kind of take hints from the underlying Java hash set implementation and kind of implement it yourself. You get better space complexity. You have a little worse time complexity because it's not going to be O of 1 anymore, but slightly better space complexity, right? So how do you implement your own hash set? Let's look at the default hash set implementation. Like, how does it work in Java? You basically have this hash table, which is basically a table of values that you're going to have to map each input to. Okay, so you have a bunch of predefined values. Any input that comes will have to be mapped into one of these buckets. Okay, Java usually does this by using the hash code. It's going to do a hash code of the input, and then it's going to map the hash code to one of these buckets. Okay, now it's going to go to this bucket. You get another input. If it maps to the same bucket, well, what you get there is a hash collision. Okay, so this bucket cannot be just one location. Each bucket is basically a list. Okay, and Java typically internally does this by using a linked list. Okay, you basically have a linked list. Every time you have a hash collision, say something goes to this bucket, it basically creates a linked list for this thing. Add one more, goes to the same bucket, it is going to add another node to this linked list. Okay, so this is how Java implements hash set, and you can do that too. There is one other thing Java does, which is it looks at what's the load factor. Okay, if there are too many numbers that are being input, well, then it kind of balances it. It starts out with a certain number of buckets initially, and then if there are too many numbers, and then these lists are obviously going to go longer, in that case it's going to say, oh, the number of buckets is not enough. Now let me increase the number of buckets, and it's going to reshuffle all of these linked lists, all of these collisions, so that they go to the new bucket. It's going to come up with a new hashing strategy for mapping the hash code to those buckets, and then it's going to readjust and all that stuff. So typically in an interview, you wouldn't be expected to do the readjusting part, but you never know. But at least for now, what we're going to do is, at the very least, you need to have some kind of a hashing strategy, right? Create a bunch of buckets, okay? Map the input. You know that the input is between 1 and that whatever billion or whatever is the number, right? So you map that to these number of buckets and put it into a list there, okay? Anytime you get an input which matches that bucket, put it into that list. Now, adding is basically doing that. All right, so you have accommodated for collisions as well. And removing is basically finding the bucket, removing from that list. Contains is again finding the bucket and scanning that list to see if that element is in one of those elements in that list for that bucket. Okay, so this is going to be the implementation. It is kind of simple. I'm going to walk you through the code and how I did it. You're free to change it and come up with some additional ways of doing it. Again, we're not doing the readjusting and all that stuff. We're just mapping to a flat list of buckets. Okay, so here's how we implement our hash set. We first create a list of buckets. Okay, let's assume 100 buckets. I'm going to create an array of 100, and they're not going to contain the element themselves. They are going to contain a linked list. Each bucket is going to be a list. Okay, so you map the range of inputs to these buckets. So you have a billion, then you're going to have a billion by 100 as possibility for each bucket. And then to handle collisions, make a list for each bucket, and whatever maps to a bucket, you put that element into a list for that bucket. Okay, so here's the approach. Let's start with initialization code. Okay, so I'm going to create this max value constant. This is again a good thing to have because it's an assumption that the interviewer has given you. So it's a good thing to call that assumption out rather than have this number in your code, and it's what's referred to as a magic number. It always helps to have a constant so that you know that this thing is max value and you use max value in your code. Easier to read, okay? So make sure you do that in an interview. So max value is this. I'm going to set the array size to be 100. Okay, this can be different. I'm going to just make it 100. Just a random, number that I've picked. Now, how do you initialize my hash set? Well, first I create a parent list. Okay, these are the buckets. Okay, this is a list of linked lists. Okay, list of integer is what the linked list is for each bucket. So this is going to be a list of those linked lists. Okay, if you think about this, you basically have a list over here, which are all the buckets. And then each element here is basically a linked list. Okay, it should be a linked list, not an array list. Let me redraw this over here. It's going to be like this. Okay, this is going to be the linked list, and this is going to be the parent list. Okay, that's what this is. This is the parent list, and each element here is going to be a linked list. I've just marked it a list of integer, but the implementation that I'm going to choose is going to be a linked list. Okay, so in my constructor, which is where I initialize the data structure, I'm going to create an array list for the parent list. Okay, and the array list is going to be initialized with array size. I know what the size is, so I don't have to have it readjust as we add stuff. I'm going to force it to 100 elements. So the parent list is going to be an array list. All right, each element in this parent list is a linked list, but I'm not going to initialize that right away. All right, what I'm going to do is I'm going to make them as null. Okay, I'm going to initialize them as null so that I don't have to do checks later, right? I don't have to check if the size is met and all that stuff, initialize it. Well, I'm going to force initialize it with a bunch of nulls. So I have that much elements in my array list. It's basically 100 elements in my array list. All of them could contain, each one of them could potentially contain a list of integer, but I have initialized them as null for now. Okay, so this is my initialization. Now, what matters is what I do with the add, remove, and contains. Okay, so here's my add. Add takes in an integer. Okay, now what do I do here? First thing I need to do is map it to one bucket in my parent list. Okay, I need to know which bucket it needs to go to. So what I do a modulo, reminder of 100. So this happens to be 100, but I could change it later, which is the benefit of using this constant over here. Now I do a modulo so I can map it to one of the buckets here. Okay, and now what I do is I get the child list. Basically, I see what is the list in that bucket. Is it an empty list or does it already have a linked list? It really doesn't matter. I'm going to get the child list for that bucket where this key needs to go. Now, if that is null, well, nobody has been there before for that bucket, so I need to initialize a new linked list. So I'm going to create a new linked list, which is a list of integer. I'm going to call it list, and I'm going to add this key to this list. All right, so it's going to be the first element in that list, and I'm going to set it to that bucket. So this index, what I've mapped over here, is going to contain my newly inserted list. All right, so it's going to be like this. So I have a bunch of buckets here, and here's my element. An element maps to, I do a reminder to map it to one bucket. Turns out this bucket does not have anything, so I'm going to create a new linked list, add this thing here, and I'm going to set this element to this linked list. Okay, there's the first element there. Okay, now if this is null, that's the initialization that I need to do. But let's say it's not null. There is already a linked list there. Well, what do I need to do then? I just need to append it to that list, but only if that list does not already contain the value. Okay, so let's say I have this thing here. I have an element and I map it to this bucket, and this bucket already happens to contain a linked list. Okay, now what do I need to do? I can't just append it at the end. I first need to check if this linked list already contains E. Okay, so I'm going to check if this linked list contains this element. Okay, that's what I'm doing over here. If it does not contain the element, only then do I add it to that child list. Okay, there's a list already there and it does not contain the element, so I'm going to add it. If it does contain the element, what do I need to do? I don't need to do anything. It's done. My job is done. All right, that is add. Okay, but let's look at the remove use case now. Again, remove takes in a key, which is an integer, and it needs to check if that value exists. So the first thing you need to do is find the bucket. Okay, again, I'm going to use the same formula. Reminder of key divided by array size is going to give me the index where is the bucket where that value might likely be stored. And now what I'm going to do is I'm going to get the list that is at that particular location. I'm going to do parent list.get of index. Now this can be null or it can be a linked list. Now if it is not equal to null, what I'm going to do is I'm going to remove that key from this list. I'm going to do integer.value of, because I don't want it to remove from a location. I don't want it to remove, like let's say key is 5, right? I don't want this remove to remove the 5th element. I want it to remove the element 5 wherever it is. Okay, so that's the reason why I convert it into an integer. I box it into an integer to make it very explicit. I want to remove that object, that integer object, and not remove that place, whatever the value that contains. Right, it's a tricky thing, and this is a problem with auto boxing and unboxing with these kind of collection APIs. Right, remove of int is going to remove at that location, and it's not going to remove the thing that you're passing in. So I'm boxing it to force it to remove the thing that I'm passing. Okay, so childlist.remove of the integer object of that value is going to remove that value from childlist if it exists. If it doesn't exist, then it's not going to do anything, right? So I'm going to do this if there is a linked list in that bucket that I've mapped to it. Okay, if there is no linked list, well then there's really nothing to do, right? That element was not added there, that bucket is empty, so I can just exit quietly. Okay, so that's remove. Next is contains, right? I'm given a key. I need to check if this contains it. Again, what do I need to do? Same stuff, right? I first find the bucket, so I do index, and then next I get the child list. All right. Now what do I need to do? I need to check if this child list contains the key. So simple. I return if child list is not equal to null. I return childlist.contains of key. Right. I'm using the contains method on this linked list to do this, so that I don't have to do this myself. Okay, so this is the contains API. Now what's the time and space complexity of this thing? Well, it really depends on the table size. It is not O of n with Hashset because it really depends on the size of the list. Okay, so there are ways in which you can calculate time complexity of Hashset, and it really depends on the load factor. It depends on the number of buckets that you have. For example, you can have the number of buckets equal to the range of n, and you get O of 1 complexity, which is what we did with the Boolean array. Remember, we basically had the bucket to be same as the range of inputs, and the time complexity was O of 1. Right? There was no need for a linked list because every element had a space in the parent list itself. So it depends on the bucket size, number of buckets, and there's a good discussion about load factor and rehashing that you can get into with Hashset. Again, like I said, Hashset has a built-in load factor, which is basically the number of inputs and the number of, it's a ratio of the number of buckets. If it's, I think 0.75 is the default load factor. If it goes beyond that, if there are more inputs that that kind of increases the load factor, well then it's going to do a rehashing, right? It's going to double the number of buckets and it's going to rehash. So that's a good discussion to have with the interviewer to kind of convey that you know what this is. If you don't know this, definitely look up how a Hashset works. But this is your solution to the problem of implementing your own Hashset. Again, there are multiple ways in which you can take this, right? If there is a lot of time, you can say how you're going to redo this, how you're going to rehash this by increasing the bucket size, and then basically picking all the elements in all of those buckets and then doing an add on them all over again. Okay, so that's one way to rehash. So with this, I'm going to conclude this video. Do check out the playlist for other such LeetCode challenges in an interview setting videos. I hope you found this video helpful, and thanks for watching.